national educator.
Hello and welcome back, Lana. Today we are going to discuss a revision work in physics and uniform circular motion. Now, uniform circular motion is the study of bodies that trace circular paths. Now, when a body moves around a circular path, there are forces that are experienced by this body. It is expected of a learner to understand these forces, their directions, and importantly, how they affect each other. Now, before we look at the problems we want to tackle today under this topic, I need a learner to understand that for any body to maintain movement on a circular path, then there must be a force directed towards the center to keep such body in such paths. Now, this force we call the centripetal force, and it is directed towards the center. It is this force, one could say, that is responsible for the planets as they orbit around the sun. There is no string holding them, but there exists a force that keeps them on that circular path, on that circular trajectory. Now, it is important again to understand different factors or things that would provide this force. For example, if a vehicle is going around about turn or a roundabout, you notice or you find that the centripetal force will be provided for by the frictional force between the tires of this vehicle and the ground. Now, that said, I want us to look at certain questions, problems from this topic. Now, Lana, we have put these strategic questions and we have tried to explain given strategies that one ought to follow to help him get the correct answer for a given question. Now, straight to it, I want us to look at the first problem. The first problem here says, and this is an interesting one, a body moving around a circle is accelerating, yet the speed is constant. You're asked to explain this. Now, conventionally, laymanly, one would say that acceleration is the rate of increase of speed. Meaning, when there is acceleration, one should expect that the speed is increasing. But here is a question of a body that is moving at a constant speed and yet it is accelerating. Now, Lana, before you answer this, one needs to understand exactly what velocity is and importantly, what does it depend on. Now, in the strategies for this, here are what I prepared for you. One needs to understand how bodies in circular motions move. Then, what is the relationship between the velocity and the acceleration? And lastly, the factors that affect velocity of a body. Now, very quickly, Lana, velocity is a vector quantity. Now, vector quantities are those quantities that have both magnitude and direction. Now, it is for velocity, the magnitude is as important as direction. So if a body on a circular path is moving with a constant magnitude, let's say 20 meters per second, but direction keeps changing, then that change in direction implies change in velocity, even if the magnitude is the same. That is why when a body is moving around a circle with a constant speed, magnitude, as long as its direction keeps changing, we consider that velocity to be